Hey, good morning.
Hi there.
Hey, David.
Hi, Adam. Good to see you.
Thank you. Good morning.
Good morning.
Actually, Alon, I don't think we need to record just yet. Or we started recording. Is it me? No. So who's the host at the moment? Oh, the host is not here yet. Actually, okay. Let me pop out and log in as the host because I came from the. Oh, Dida is the host. Hey, Dida.
Morning, everybody.
Morning.
Yeah, I think you can stop the recording. Hi, welcome to this threat modeling session of the SafePaths COVID application. We have some amazing participants and co-organizers from the app itself, and some of the great presenters that Mark and Jay, who presented on Monday. And what I just want to do now first is just give a quick welcome to the summit, to the sessions we're doing. And then I will go and do an introduction to the threat modeling process, and then we crack on with actually looking at the app. And I will just prefix this by saying that I think it's a great opportunity for us at the summit to be able to help with this, and it's a perfect app to help. It's fully open source, it's fully transparent, it's already done a lot of great strides in security. It's probably already has a lot more security maturity than some of the other apps that are out there, and I think we can make a big difference to help out, right? And like Adam will say, for some of the things I will highlight, his request is going to be great. Can you do something about it? And I think we as a community need to step up, right, and actually do something about it. So there's lots of areas to help. As you will see in this session, I'm going to go in a lot of different tangents. This is the first of many sessions. Tomorrow there's going to be another session at the same time. And the key point here of this session, so the key point of this session is to try to understand what are the places of highest leverage. So just before we do that, let's just quickly a quick intro to the summit and what you do. So expect you to participate, to ask questions. This is kind of a collaborative session. Please respect everybody. Let's be let's be courteous with everything, you know. Always remember that there was a reason to do something, right? Especially when we start to look at code, it's very important to understand that there's always pressures, there's always development focus, there's always things that are on somebody's mind. Nobody creates a vulnerability on purpose. And it's very important that, you know, we have that. And I mentioned this to Adam, but I say it again, I apologize if sometimes I can sound a bit too harsh or too rude. It's just that I tend to think a little bit fast, and I tend to kind of go on rabbit holes. So, you know, apologize in advance. But again, you know, try to keep objective distance on your comments, you know, but challenge individual, and let's focus on the solution. And the solution here is we want to make this app as secure as possible. We want to make this app as privacy focused as possible. I want this to be an app that I'll install on my phone, that I get my kids to install, I get my mom to use, I get my friends to use, and I'll be, you know, be able to look them in the eye and say, yes, this app is as secure and as privacy focused as you can get, right? So that's, you know, me personally, I also have that agenda. Everything in the sub is openness. We record this, we share everything, we put everything in, you know, social media, in YouTube, and, you know, if you want to be identified, then, you know, just don't put your camera on and use NA. And everything we want to do is release under Creative Commons or an open source license. And in this case, it's great because, you know, this project is already open source, is already released under Creative Commons. So, you know, everything is there. So everything we add on top of this is released under that licenses, which is really cool. You know, respect, this is massive for us. You know, we've been doing great so far. Let's keep it that way. You know, everybody please be professional. You know, if you feel any kind of abuse behavior, let us know. We take this very seriously. We have very low tolerance for any kind of abuses. Everybody should have an opinion. We don't have to agree with everybody. That's part of the point. You know, I like the idea of agreeing to disagreeing sometimes. And what's important is to have rational points of view and be, you know, very respectful for the other person. So finally, share your views. You know, there's a Slack environment. You know, in fact, Slack is a great example of how this started. You know, Ivalabi sent an email to Adam. Adam responded. I said, hey, dude, can you pop into the Slack channel? You know, within, you know, 3 or 4 Slack messages before we had this session, right? That's how it works, right? That's, you know, that's how the sausage factory, that's the room where it happens, right? In these situations. Yeah, join. And of course, you're here to learn, right? You know, we're here to share your views. You know, I've done a lot of training in the past, and I always view that the best thing I can do when I train is to share how I think, is to share my approach, is to share how I approach a particular problem. And hopefully you'll see that the patterns that I follow, which is also followed by the industry, are very common, right? You know, but, you know, everybody struggles. And you know, and for example, at the moment, you know, it's a very challenging for me because I'm basically looking at a really great app developed very well, and I know very little, right? So it's kind of like, it's always a lot of interesting pressure when you're doing these things, right? But again, so everybody's learning. So let's go into, I want to quickly just run you through this deck because I think threat modeling is a really powerful workflow. And the thing that I try to do, right, and I tell this to my team, is that you don't do threat models for security, right? Although security is a driver for threat modeling, although security is one that has a really nice stick to promote the creation of threat models, fundamentally, the developer teams should be creating threat models because they want to control the project brief and scope. So I'll walk you through that concept, right? So fundamentally, threat modeling is just a process for, you know, optimizing the security by, you know, identifying, you know, objectives and vulnerabilities, right? And countermeasures. Basically, it's asking the what if, right? It's fundamentally, in a nutshell, DFD diagrams is, you know, architecture diagrams. And then we just ask a bunch of questions. We do a pen test almost on paper on the system. And we basically raise the awareness of security, but also we define sometimes the scope of what you're trying to do. So the reality is that the sooner you do a threat model and the sooner you build that system, the better it is. The last place you want to do a threat model is at the end, right? Because then, you know, if you find stuff, right, it's, you know, it's really hard, right? And by the way, Mark, Jay, and Adam, you know, feel free to chip in, right? If you want to, you know, agree or disagree, right? The stuff that I say. So this is a great quote, right, from Michael Howard. who, kind of, is one of the godfathers of threat modeling. And I really like this, right? And he's basically saying that if you don't understand the threat of your systems, you have no idea how exposed you are, right? It's literally that simple, right? And the best way to address a risk, the best way to address a vulnerability or a threat is to understand about it and then be able to make rational decisions about it. In security, we're really bad at making bad recommendations and bad decisions because sometimes we ourselves don't understand the systems, don't understand the threads, don't understand how everything fits together. So it's very easy for us to say, focus here because it's really bad, where in reality it doesn't matter, right? I love some of the slides from Mark on Monday because there was clearly a point where I was showing this thing and I was looking and going, whoa, that's massively over-engineered, right? Like in my head, I'm like, there's so many moving parts to get right that actually building a maybe less secure system, right? Although I would argue that a GUI is still pretty freaking random, right? Is actually better, right? If it means that you have less moving parts. Right?
This is actually a really good point. I mean, the nice thing that threat modeling gives you is that, so in security, from the researcher point of view, which is where I come from, like finding vulnerabilities and identifying CVEs and whatever, you often sort of give a score, CVSS 3.1 score, and you're kind of like, okay, cool. And there's so much focus on that number. And what if it's a 5, it must be fine. Yeah, but a 5 in one context doesn't mean much. A 5 in a different context gives me administrative access to a server that I shouldn't have. Because it wasn't captured. The CVE is only part of the story, and the threat modeling. This is something which we talk about a lot in security. Jay's given some really good talks about like shifting left in security and trying to involve developers, because if the developers are thinking about threats and how they're going to mitigate issues ahead of building software, then you're on a better foot. Cryptography is a really good point. Like in IoT, I've been saying this for years, and just in general in an enterprise setup, if you want to change a cryptography decision, you've got to change quite a bit. So it's very hard to do cryptography backwards, which is why I kind of looked up so much of the cryptography for these things, and I've sort of raised a lot of questions and rattled a lot of pans just to sort of get an idea of like what is actually meant by this particular thing. When you say that you're going to be encrypting this or moving this, then this is, why are you doing this? How are you doing this? And then sometimes people go, oh, we're doing it because of this. That's great. Other times you're going, well, why are you doing this? And they're like, well, it looks good. It sounds good. It might even be good, but there's no guarantee. You see. I think Jay's got probably some thoughts on shifting left of threat models and that kind of thing.
I basically just agree with everything you say, to be honest, as always.
We're very readable.
But yeah, I think you're totally right. This is about giving tools to people, methodologies, in order for them to make sure that they are developing things as securely as possible. I think in security we do have the problem. We rely a lot on it being security people to do it, and security people work in different ways. We want a finished product. We want something that we can actually start looking at and testing. Threat modeling lets kind of non-security people take the knowledge from security people and apply it in a different way. Cool.
And there's one more point is that that's the quote, right? Like when you see a good threat model, it's fundamentally you also show that there's been some time spent about thinking about end-to-end design. Right. And actually, sometimes you can even take security there, right? Sometimes threat modeling forces you to actually think about the design of what you do, right? I've done so many threat modeling sessions that start with 3 people in the room and end with 25, right? Because every time you ask a question, they don't know. And then they go and get somebody, and then that person ends up staying. And then halfway through, they're going, oh, look at that. That's how it works, right? I never realized that's the thing, right? And then you find these spectacular vulnerabilities because you go, well, what happens here? Who does this? Who's responsible for checking these data or authorize or validate this? And then because, well, those guys do it. And they said, no, are you supposed to do it? And then, whoa, hold on. That means that, we're not doing any of this stuff, right? And especially on the back end and the microservice architecture, a lot of those systems are just glorified proxies. So each layer just sends the data to the next layer down, right? So, so it's very important to see a threat model that forces you to think about it, but also it allows you to scale, right? So if you think about it, like when Mark and Jay start looking at an app, if they start with threat models, if they start with these diagrams, with these views, they are so much more efficient, right? They are so much more effective in their use of time because they only have a limited amount of time to spend on this, right? So in a way, we want to maximize their efforts, right? So that's kind of the key elements of this. So that's kind of the basics, right? You do assessment, identify, understand the existing vulnerabilities, countermeasures. So we go through this, which is kind of like a loop, right? And a lot of this is how we think, right? We identify the kind of things we want to do. We look at the app, we decompose it, we map the threads, we identify some vulnerabilities, we map the risks, very important. It's also very important to take into account the threat actor, which is something that I want to do. And that was a great session on Monday where we're going to be able to create some cards with the threat actors. And I think it's very powerful to also understand who is attacking who here, right? Or who is the threat? And the threat could be a rogue medical agency. The threat could be a rogue internal employee, could be a rogue user, could be somebody abusing the system, could be, actually, I was reading the document you guys wrote yesterday, right? It could be somebody that wants to, damage a business, right? There's all sorts of stuff that will come out once this kind of goes out. So it's very important to understand, again, who are you protecting against who? Right, and that tells you the threats, right? I feel that a lot of this conversation about privacy, part of it loses the point because there's already a lot of places that we leak our privacy, right? So I actually think this is a great opportunity to even raise the bar, right, of what we call a secure app, right? What we call a secure environment, right? Which is quite good. So a lot of threat model is just this, right? We do a data flow diagram. We kind of actually that should be DFD, right? I just realized. So basically where we map the beginning, this is very simple. I'll go into more details later, but what we can then do is ask this kind of 6 questions, right? Or look at these 6 threats, which is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, right? And what that is, in a way, is it's a way to think about the application, right? So when I look at those, and like, think about it, like when you're doing a pen test, you're following the packet, right? You're following the flow, you're following how things are stitched together. So when I'm talking about spoofing, I'm talking, all right, who knows who, right? How do I know that you are who you say you are? What happens if I pretend to be somebody else? What happens if, the server now can be spoofed? What happens if the client is spoofed? What happens, it's like, how do you authenticate across the system, right? And it's very important that you have to authenticate everything. Right? We have to authenticate every single player or create a system where authentication doesn't matter, right? Which is also another way of protection, right? So if you have systems where it doesn't matter, then it's great. So tampering is about how do you handle the data? Are you modifying data not supposed to be modified? What about data integrity? And this can cover both angles. Repudiation, I think, is very massive here because, it's something you have to take into account because how do you know when somebody says X that that person's X? Like that thing on Monday when you showed me that app that used the mobile phone number, right, as an identifier. I was like, do these guys realize how the mobile phone networks actually operate? And how the fact that today, annoyingly, right, it's actually, I think, a massive problem that you get the mobile networks are not able to give you a unique ID per number to confirm that you actually being contacted by a person that actually has that number. Right? So, which is a massive problem in the mobile phone networks. Information disclosure, are we leaking out data? And I think on this one, I think de-anonymizing data and de-anonymizing the user is something that is very relevant. And I know that, there's a lot of focus on this. My kind of view on that one is, I think that we need to also be very clear when that is possible. Because the bottom line, there will be always corner cases with this, right? Even if it's an extreme case where I'm literally sitting next to Mark for 2 weeks, right? And, we haven't moved and then he goes pop and then he goes, yes, I got it. And I got a notification that, oh, hold on, that person just got it, right? The bottom line is that you're always going to be able to de-anonymize the individuals. The question is, how do you do it? Who can do it? What's the side effects? And what are, like you said, what are the people's decision about it, right? When they're happy with that and who controls that, right? I think the denial of service here is a really interesting element, because I think that there's a lot of ways that these systems can be abused, right? And you have to be careful that, you know, some of these platforms, right, when you look at scales and millions in terms of requests, right, things change a little bit, right? And especially node applications, I've seen cases where, you know, something that takes a millisecond to run, it's great, but I call it 1,000 times, and guess what? That just took a second, right? And I call it 10,000 times, now you got your application stopped for 10 seconds, right? So, you know, and we have to be careful with that. And of course, elevation of privilege in this case is the whole authorization. So if you look at this, right, what we're talking about is looking at authentication, integrity, non-repudiation, confidentiality, availability, and authorization. If we get those right, we have a really good app. Now literally just covers a really nice set of topics, right, on this. And the logic is you ask those questions on the diagram, right? So the diagram should be able to give us those answers. And the whole point of this is that it's a graph, right? So, you know, like Mark was saying, you know, you might have a 5 here, you know, CV5, but actually the way that is used actually creates a massive problem, right? Where you might have a massive vulnerability here. You might have passwords in clear text in the source code. You know, like security guys go bananas. You go like, what cares? You know, if the attacker can't reach the database, it doesn't freaking matter, right? Yes, you know, I can argue that it's best practice. I think that I have a bigger risk, which is the fact that you don't have a good CI/CD pipeline that handles that, which is probably the bigger problem, you know, not the password, right? But, you know, it's very important that we have these graphs, that we understand the permutations and the connections with this. And all of that will be mapped in Jira and YAML files. So very quickly, you know, we can ask questions about this. We can ask questions about each of these stuff. There's actually some really also cool OS projects and stuff and cards we can use. But a lot of these things, you know, I find that, you know, once you get the thinking of it, you know, even the developers actually themselves, right, start asking really good questions, right? In fact, I know that we're doing right when it's the devs who actually are finding the vulnerabilities themselves, because they're going to go and go, oh shit, if that's a problem, then let me show you what happens over here, right? Because they know the code way better, right? So a lot of times we start with paper in a good old analog days when we actually sit in the same room, right? So again, I found that sometimes literally this is the best way to do it, right? Although now we're going to try to do it a bit more digitally this way. And this is one of the concepts that I really want to stress, because I've seen this work in real world and it works a beauty, right? Like as a developer, one of the things that is very challenging, right, is that they have a constant flow of business changes, right? Most security vulnerabilities occur because of a business change. There's somebody who said, I need this feature, I need that to happen. There's a priority, just make it happen. And then the compromises to make that occur cause lots of vulnerabilities, right? And the way I look at this is that we can use threat models to actually control that, to actually, you know, basically have this flow where you might think it's a simple change, but they have major implications, right? And that means that if you make a change and your threat model change, then it's not a simple change, right? A simple change is something that I can code all day without changing my threat models, because I'm using controls that I've created before, I'm using modules that exist before, I'm using components, I'm connecting the dots in the Lego block, no threat change.
I think it's also important to stress, Dinis, that you can also use a threat model so that you are sort of controlling the business from not going crazy, but also to enable business and say, well, you want to make this thing, but that's fine because our threat model handles that. You know, so it doesn't just restrict, it also enables, because you understand the risk. It's getting everyone on the same page so that they can make effective decisions, business decisions, you know, for and against sort of bringing in technologies, and everyone takes some kind of ownership of security because they understand their role within it. So this is what I think you're saying is really, really powerful.
Yeah. Oh, you're spot on. And one of the processes that I wanted us to do here is all the risk acceptance workflow, which is all about making the business accept the risk. And in fact, what I've experienced, and this is a very important point, is that a very good app and a very good development environment is one where you can make tons of changes very fast, because you have good CI, you have tons of tests, you're comfortable making change on your application because you understand the side effects. A bad app and a bad development environment where everything has to be done with, you know, gloves and you worry that the whole thing is going to break, right? So the bottom line here is that once the more we do this, actually the faster the business can go. And that's the caveat, right? The kind of element here is to say we're doing threat modeling, we're doing security, not because we want to slow down, but because we want it to go faster, right? It's like brakes in a car, right? It's like the difference between Tesla, architecture and the petrol engines. If you look at it, the Tesla has, I think it's 30 parts in a car, right? In an engine, you have freaking 100 probably in just one component, right? So again, the moving parts that you get in a Tesla production line and the things that can go wrong there are much lower than on the other cars. So this is the same thing. Security in this case is about the more we create reusable, secure components, the more the app is solid, but also the faster it can go, right? And that's what I mean by locking the brief, right? Because if you think about it, the reality is that you can have these requests that they look simple, but if they don't fit the current architecture, they will change a lot of things, right? And that's a massive problem. So in a way, threat model forces you to lock this. My best story was this place where I was working that had a really good network of security champions, and I get called by a security champion to a meeting because he wanted me to do a threat model for a new feature that they needed to add, that they couldn't find a good, everybody knew that it was a bad idea, but they couldn't find a good way to tell the business why they couldn't do it, right? And it was very simple, right? Basically, the business wanted to capture the postcodes, and they went to the identity team and said, can you add the postcode to your data? And the identity team said, sort of, because we barely are keeping alive. We're just doing authentication and that's it. So they found this service that was able to capture millions of entry points every day. They literally were able to capture all the data, and they scaled and they cloud-based, and they basically said, cool, you guys already captured data. Can you just add the postcode to it? The problem is that system was not designed to handle private data. So suddenly, when you add the postcode, you have personal identifiable information. The threat model to capture a postcode versus capture where you clicked and what you've done and other things on the page was very different. So once we start adding everything that you need to add to their system to be able to handle private data, then to encrypt the data, to manage it, de-anonymize it, protect, make sure that one user cannot get user from somebody else, even the business manager going, oh, maybe that's not a good idea. So it's a good example of using the threat model to show, look, my thread looks like this. With your feature, it looks like that. Now we can still do it, but it's going to be a lot more expensive, and it's going to take a lot more time, and you're going to have to accept those risks, right? And that's why I like the idea of this. And the other thing it does, which is never a bad thing, it puts a gentle, positive break into the business requests, right? Because the other thing that happens is somebody comes up with an idea, right? And I tell this to my team, right? I tell them, when I ask you to do something, right? I'm not giving you an order, right? I'm giving you a suggestion, right? I want you to push back and tell me the side effects, right? Of what happens. So bottom line is we lock the brief, right? So the other thing that's very important is that, Adam, if I say, where's the source of truth for all your documentation, all your diagrams that represents the code as it was published yesterday or this morning?
Yeah, that's a difficult one. On an open source project, so we have a number of documents in Confluence, which I think are shared on your Summit site. We have a privacy and security repository, and we have the code. But the nature of open source means the decision-making is decentralized, the work is decentralized, which is why we need to focus on this threat model to prioritize the security verifications we've got to make sure what we think people are doing is what they've actually done.
Yeah. I think I realized I'm sure introduce you also. Adam, our rock star from SafePaths, and also there's another colleague of yours here, right?
Yeah, Diarmid.
Hi there. Yep.
Oh, cool. Now you guys are amazing. I think what you guys are doing here is great. And by the way, right? I don't think it's an open source thing. In fact, I think open source does this better than most other products, because I think the commercial and the closed software, they get away without, because they don't have scrutiny. Like the reality is, because you have to deal with already contributors, the level of quality of your documentation, of your onboarding, of your, can I start this app, is much bigger than most apps when they develop by even teams of 10, 20 people, but it's a gigantic freaking hack, right? And because they had nobody else contributing, they don't have that pressure. right?
Yeah.
And look, Agile is the ones who said the insane concept that we don't need documentation because we go fast, right? Like literally, right? And then you ask them how the hell your app works, and nobody understands, right? Because the guy who wrote it is long gone, and and then all this stuff. So, and I going back to the thread model and the acceleration, I take the view that the more documentation you have, the more visibility you have, the more understanding you have of how it's supposed to work, the faster you will code, right? And the easier it is to contribute, and the easier it is to develop on your application, and in a way, the easier it is to secure. The problem with you and everybody else is how do you do it, right? Because if I go and look at your backlog, I'm sure you have some items there to say, let's document this better, let's create an architecture diagram, let's update this to, to the latest design, let's double check how everything works, right? But somehow that always gets deprioritized,
That's right. And I think unlike most open source projects, we've got a public health emergency, and we've got health authorities that are crying out for the application. And it's, there's got to be a trade-off as well in terms of, how much can we possibly do before people need to go live?
Yeah. And this is where I feel we as security can add a lot of value, because in a way, in security, you detached a little bit from the deployment, right? You detached a little bit from the actually having to ship the product. And our focus is almost empowering you to ship a secure product. And so I actually think that security teams and security professionals are perfect to help with that, right? Because the bottom line is that we need it to do our job, right? The reality is, if I'm coming back to you to answer the question, is my app secure? And I don't have visibility to how your app works, how the hell am I going to answer that question, right? Look, the dirty secret of the pen testing industry, right, is that the game of a pen test is to find enough shit in an app so you don't have to answer the question, is this thing secure if I fix all of it, right? Because the hardest apps is when they're really good and suddenly you're faced with the question, is this app secure? Because you haven't found anything major. And at that moment in time, if you hadn't had a lot of visibility on the app, there's no way you can answer that, right? Truthfully, right? You could say, well, as far as what I looked, it's okay, but I haven't, looked very deep, or, it depends how much time you get given, right? Of course, right? So that's the thing, right? So the way I look at it is that the more information we have, the more automation we have, the more that security tests are automated, the more real-time information we have, the more effective and the more secure, or the more understanding of security we know, which basically leads to the point that your security architecture has to be created from code, right? The only way the diagrams scale is when the diagrams are programmatically generated from your code, so that when you make a change in the code, if the diagram changes, you need to do a review, right? Because that's the only way to scale. Or else you end up a situation where you can have great diagrams and then the code doesn't actually match, the thing, which is what Jay was saying, that he has a lot of success just by making sure that, the things that are said publicly or how you think the app works is actually how the app works, which is, in security is always, trust but verify, right? You always double check that things actually work. So threat models can be an amazing source of truth, right? Because in a way, you should have a requirement to do a threat model for every app or feature, right? And the simple question is, right, that if you don't have a threat model for a new feature, it means that you don't understand the security implications of that feature, right? And that's super critical. So that means that, and then usually in my world, I'll create a risk for you to accept. In fact, for you to confirm and for the business owner to accept. So if you're adding a new major piece of functionality and you have not done a threat model for that functionality, then what you're saying is that you don't know the security implications of this new feature. So somebody has to be responsible for that, because that's a conscious decision that was made, right? Not doing something is doing something, right? Which is not doing, right? So when you choose not to do a security review, when you choose not to do a pen test, when you choose not to do a threat model, and maybe it's because you don't have the resources, right? Maybe you don't have the budget, maybe you don't have the time, maybe you don't have whatever, but it's still a conscious choice, right? That has to be done by somebody who has to accept that risk. And that's kind of the key game here, right? So the reality is that it's easier to do a thread model workflow than to have a requirement to have up-to-date documentation and diagrams that represent the real world, which very few teams I've seen can do without a lot of automation or without thread models. So this is where, again, another area that I think in security, we can add a lot of value, because we can basically say, let's help with this. We'll help you to create those documents. Your job is almost to confirm that they are correct. And then we can use them to do our analysis.
That would be, if you have an open source tool that could help us get data flow diagrams in place to validate what we think is the data flow, that would be absolutely fantastic.
Well, that's what we're going to do. My biggest frustration is that I had this conversation is like Groundhog Day, right? I had this conversation many times before. My biggest frustration is that I could never share the stuff that I create. So I always feel that I have to go back. I don't mind doing Groundhog Day as long as you start, a couple of hours later, right? So you don't actually go back to the beginning every time, right? So the other thing I really want to get out of this is to actually do those things in an environment where you do share everything, where you do create those tools. Because I've coded some of them, and I work with teams, I coded some of them, and I'm going to nudge them to say, oh, can you guys freaking release some of the code we create? But that's out of my control, right? I was a contractor, right? I wasn't the CISO where I could get to decide, what we open source or we don't open source. But that's exactly one of the things I want to get out of this, right? I want to get that automation, which, by the way, is there's always a bit of custom build, right? There's always something that's specific to your app, right? The point is to then create all the other modules that are more usable. So that's one of our objectives here. So for the developers in a room, that's basically what we want to build is a graph that is basically a parser for the codes and a way to then map that to a graph that we're going to put on YAML files or Jira tickets that we can then graph and make the connections. And then the logic is, as the code change, you analyze that again, and then you push it there. Cool. So the other thing that, final key concept here, is that the way to scale thread models, right, is not to do, let's freaking map the whole thing, right? Because that doesn't scale. And also what you do is you mix context, right? So my best experience this is you do a thread modeling per feature, right? And then sometimes the best way is to follow the user journey or to follow the use case. So basically we take very specific path, and that's what I want to do once we go to the session, is let's take a very couple specific use cases, the login flow, the create organization, the sharing of the data, how some of the bits work, and then we kind of follow it, sometimes all the way to the code, right? And that allows us to really understand all the moving parts, all the assumptions, but also what you don't do is you don't mix concerns. So a good example is that when we look at how the data stores secrets in the back end, that should be a thread model just focusing on managing secrets in the back end. And then what it means that as you find the places, for example, where you don't manage data correctly, or the places in the back end where data gets stored and encrypted, right? Because that's one of the things that is, you want to do properly, right? Then that becomes almost a vulnerability that is inherent by every other system that uses that component. So you got these almost graphs within graphs. So I know that, I have, secrets that that I'm not storing correctly, because in my path, I go through that server, or I go through that step, or I go through that thing. So that's how you compound. So basically this gigantic graph, and then the final bit is to make it into a map, which is really cool, right? So then you apply the worldly map stuff to it. So basically you take the paths, you map it out, then you create a full flow of it. And this is where, for example, if you have a user journey diagram, if you have user flows, if you have, some of the best diagrams I've done was when the UI and UX team literally came along with a massive thing and says, here's all our journeys. Here's how we think. In fact, here's how we expect the use case to behave, which is great, right? Because now you know that any variation of that, it's a vulnerability. And sometimes I found myself doing thread models that I go to the business and say, here's how you guys operate. Literally, you think the users do this? I'm telling you they don't, right? Do you know how many login pages you got? We found 14, right, in your application. So, real world, actually, the best one was 35, right? Login pages. right? In an application, a big app, right? But there you go, right? So that's really cool because we can do that, right? So then you map the inputs, you map the outputs, and then these scales, right? And then you actually see, what ends up with who and who calls with who. And actually, for example, on GDPR, there's some really cool stuff you can do because GDPR also forces you to track the data and then the right to process, and then who's supposed to touch it, and where does it go, and do you even have the authority to do it, and all that jazz, right? So it's a great benchmark. So eventually, by the end, you have really good tight briefs on this. And then finally, like you mentioned out, you chain the thread models, right? So your thread models are mini graphs that they come together. And sometimes you want to see the big picture, which is cool. But a lot of the times you're just seeing a slice of your graph that answers your questions. So fundamentally is when, Jay doing his pen test, the questions that he asked, most of them should come up with a graph. And then we can do the analysis, right? And that's a great way to scale. So when Mark is asking questions about the cryptography, a very good question is, where's all the places in the source code that touch cryptography, right? Where's everything in the code? And then you find like a simple app, it looks like one bit. The over-engineer app that we look about is a gigantic freaking blob, right? It's like freaking everywhere, right? And you have tons of secrets and tons of things, and the single point of failure should be very clear because we'll see, for example, everything going to one key. That's like, hello.
This is actually really interesting, Dinis. The way you're talking about it, I think there's a conversation that we should have, not here because we're trying to keep some kind of focus, I think, but there is kind of a growing idea in my mind of using more and more graph theory, directed graph theory in particular. Which there is. So I'm a mathematician, for those who don't know. My background is in mathematics. I like numbers. Numbers, I think, like me. Yeah, I think there's a whole conversation to be had there. Now, the way that you're talking about these algorithms, there's names for those things, and if you then marry things up, I think there's a lot of potential for really sort of streamlining a lot of stuff. But we'll just pin that for the future.
We're going to create another session on that. But that's exactly where I'm going, right? What we'll see is, okay, I won't go into, I'll search, me and graphs, but I'll send some links if you want. Like, that's exactly where I'm going, right? Like I've been doing that, in fact, the way we use Jira, like, we have Jira like a gigantic graph. Like we actually have 55 or 70 issue types in Jira, right? Everything in Jira is a ticket type. We got, vulnerabilities, risk, assets, entities, components, people, teams, facts, vulnerabilities, questions, meetings, everything, almost anything you can touch and think about, it's a node in our Jira. And then we just connect all the dots. Right, cool. So, again, some of the stuff here is like, we change the threat models, and then, you understand, and then that whole thing of going like, hey, we get some data from over there, we trust their systems, and we're supposed to have, for example, this protection, and they rate limit their requests. Actually, when you do this, you realize actually they don't have that, and then it gets very, problematic. So when I was looking at the architecture, for example, Adam, I noticed that you guys go and consume data from multiple providers, right? And you actually go and load data from them, right? And you give them data too.
Yeah, multiple healthcare authorities, yes.
Yeah. So for me, immediately, it was like, all right, so there's a lot of interesting things. First of all, not only you can denial of service them, but also they can denial of service you. Right? I actually remember once was doing this thread modeling on this team, and they were doing a homepage for a very big news organization, and it was the new redesign, and they scaled it out spectacularly. So every component was now making calls to all the different systems, right? And load it up, nice Kubernetes, super scaled. And then I asked them, this is great, but do you know if the guys on the other end can hold your load? Because you just show me that you can scale as no tomorrow, but can the people that you call to actually survive your level of calls? And they're like, not sure. And then I did another threat model 2 months later, and they're like, yeah, we kept blowing up all sorts of systems. So they had to put all sorts of caching and almost rate limiting in their end, because they would easily destroy the weather service, like literally, because it wasn't designed to handle that amount of traffic. But also they had problems with misbehaving services, giving them data that will actually gum up their whole page. Right? So it's very interesting again from a threat model to understand where do you depend and where you don't depend.
This is a really interesting example, Dinis, of where a threat in a threat model doesn't come with any necessarily malicious actor at the other end of it. It could just be that they just turn on a service and then everything falls over.
Oh, yeah. Oh, absolutely. Look, malicious actors are just an externality that is invoking existing threats. right? And in fact, it's a threat that is being executed by a rational actor versus an irrational actor, which is a bug, right? So a bug will be triggered by a number of events, but it doesn't respond, right? Well, at least not consciously, right? Where the problem with an attacker, especially more sophisticated ones, is they will react, right? And they will do things that, you didn't expect. But the bottom line of this, and this is my experience, is that the more you do this, I guarantee you that 90% or 99, depends on your threat vectors, right? Of what you'll find are bugs. You literally will find bugs. You'll find misbehaved code. You find mistakes that you've done. This is the one that really blow my mind, is I found mistakes that I would do. And I think, shit, I should know better. But guess what? We make mistakes. You code the wrong thing, right? You fat finger something up, right? You wire a connection that you're not supposed to be wired, right? And then suddenly that just causes a massive problem, right? Over here. So basically bugs and users, right? The difference between a power user and an attacker sometimes is very fuzzy. In fact, what you find, especially on some commercial elements, is that your best users behave worse than your attackers, right? The problem is you can't get rid of them because they're the ones that everybody loves. So I remember the early days of social media, I think it was Metallica or some other company, not Metallica, whatever, somebody else, right? Was that their guys, I think were buying, the PR teams were buying all these tools to create bazillion of accounts and to spam everybody to like them, but everybody liked the band at the time, so everybody was happy, right? They were, oh cool, this band just tagged me to be their friend, love it, right? But they were literally behaving just like a bad actor, right? So I think you find here that you might find that, especially on your situation, you might find that health authorities that are really good at what they do, they might behave in your system almost like an attacker. In fact, I actually had a better example. I remember this trading application that kept crashing every Wednesday at 2 p.m. And they had no idea why. Literally every 2 p.m. for a bunch of weeks, the freaking thing would be brought down to his knees. And guess what? The vulnerabilities, they had no logging, no monitoring, no understanding, that's the real problem, right? What was happening was actually a mobile app developer realized that they could download everything, right, in one go, right? And literally at 2 o'clock, they would start the mass downloads, and they knew that the system would crash. So they would detect when the system crashed, wait a little bit, it got up, and they kept bringing it up. So literally, and they said, look, hey, it's their system, right? So they literally would, for half an hour, dump everything and then push it to their clients. So the clients were super responsive. And then you get the delta, right? It's a good example of actually a good, and they were, generating tons of money for the company, right? So you can't ban them, right? But you have to work with them, right? Cool, all right. And then the pen test, and this is finally the point. The pen test confirms the threat model. So pen tests are super critical because the point of the pen test is they should be validating the threat model. They should be validating your assumptions. Is that independent review and finding the gaps, right, of this. And my party trick when I used to do pen test is to go to somebody and say, can you tell me what's in here, right? Because if you cannot tell me what's on my report, in fact, I already added because I know you don't, but it's a bigger vulnerability because you should be able to tell me what I exploited, what I discovered, what records I extracted from your database, how deep I went into your network, right, and the problems I found. If you don't know that, you have bigger problems than whatever vulnerabilities I just discovered here, right? So the pen test, it becomes this healthy, almost like this virus that keep beating up the system, these things that keep hitting the system all the time. And in fact, like the bug bounty crowd, right? Like, hack away, because that gives you that almost like immune system, keep making sure that it's being tested. And the bottom line is that you wanna find out from the good guys versus from somebody abusing the system. So the beauty of this is that if you give a pen tester, which is a professional security researcher that know what they're doing versus just some, body who's just, hitting away, they, giving them a threat model will make them 10x or 100x more efficient, right? And that's what you want. We only have X hours of Jay or somebody else or me that can dedicate for pen testing. The point here is not to show you how good we are, right? The point here is to evolve the security to the next level, right? So when you do pen testing by just throwing an app over the fence, you're being stupid, right? Because you want to give the people doing the pen test all the source code, all the documentation, all the threat modeling, all the systems in place, everything, so that they can validate your assumptions, right? And if they can validate that, then you know that, okay, my threat actor today is at the level of that pen test, which is cool, right? Because, we're not defending against nation state attacks, right? But if we can survive everything that Jay and me and other pen testers can throw at it and code reviews, etc., you'll be in a great shape.
Yeah, I was just want to add about cost as well. I mean, pen testing can be fairly expensive in itself, but of course, when issues are found at that point, it's like, super expensive to then go back, try to fix the design. And I've worked with companies in the past where the cost of fixing it was too high, so they had no choice but to go live with the issues that we found. A better approach really is when you are doing threat modeling. A few hours with a security expert at that point has way more impact than days and days of time at the point where everything is complete. So yeah, I just wanted to bring that up as well. The cost can work out much better by using almost the same people or the same knowledge, but kind of earlier on makes more sense.
Yeah, and look, fundamentally, right? You have to remember that it's an economic model. Right, like the whole eyeballs conversation is correct, right? Open source has more eyeballs. The problem is some of the eyeballs are quite expensive, right? And they don't have a lot of time. So we have to make sure that you get those. Cool, right? And then finally you capture the stories, and then you celebrate it. So internally, right? It's very important for the if anybody's looking also internally, it's super important to amplify your successes, right? Because you also want to make the individuals that found these things the stars, and that's how you scale this, right? It's also very good for their career, right? So there's a lot of great careers that I help and facilitate doing this. And final step: every threads are captured in Jira. We're going to do this in Jira. We're going to accept the risk. Everything goes in there, no matter how small, and then we go from there, right? And cool, right? Sorry, it took a bit longer than I thought, but I think it was important to kind of go a little bit in detail. Actually, just maybe one more little thing here. So we're trying to create this place where they already done a great work here. So let me just sorry, you guys can still see my screen, right? Yeah, you can see my screen?
Yes.
Yep.
Yeah. So if you look at the site, it already has a lot of great stuff in here, right? So they already got a lot of great documentation, that they provided. There's the website that goes in here, and then there's the GitHub repo. Love the openness. There's the actual. I think this is the main app, and there's the back end, and there's the front end. Sorry, and there's also a really cool already section for security, which again top marks, right? So we should be contributing to this. But the other way, it's like, in order for us to have speed, I've also created this repo that we can start to put information. So for example, I put all the documents that you shared, right, in here, and I also start to link them from here on the website. And these things make a difference, right? So not being funny, but I was reading this morning, right? And it really helped me to actually go to the Summit page and just like flick through it and understand it. So we could also use the Summit website and the structure to create this information, and then let the safe paths and you guys decide how you want to do it at your end. But I think it's the way I look is that we have resources from our side to collaborate and to try to accelerate. So I'm always very conscious that we're going to be going on tons of directions, and there's a lot of innovation and pioneer work that we're going to be doing over the next week or so, that I want to make sure that we have a nice safe place to do all that without causing too much disruption. And then Adam, you can start to say which bits you want to bring into your world, right, on it. And now I think we can go over to you, Adam. Can you give us an introduction?
Yeah. So I think I'm going to start off with just talking a little bit about the whole goal of the project and what the functionality is going to deliver, because it's a bit different to the sort of exposure notification stuff the NHS has been pursuing and that Google and Apple are pursuing. So I guess, first of all, the goal is to be privacy protecting as much as possible. There's always trade-offs in this. and also to be open source. So that's not just about opening ourselves up to scrutiny. That's also about smaller countries, developing countries who don't have the resources to go and build their own infrastructure for X million. The nature of being open source is really interesting because it has a number of different effects on security, on predictability. Some of the great things I'm seeing is the countries that are like about to roll out, you know, they're taking their code base, they're making changes, they're feeding code back in onto the main trunk. They're contributing to teams of developers to make the product better, which is fantastic. It does lead to, as I was saying before, decentralized control, decentralized accountability, which is great for volunteers. It's great for people. It's kind of difficult when you want to know that you're going to have a product in a certain state by a certain time, because people have different amounts of time. People tend to want to work on stuff they're interested in. You know, in an enterprise, I can go, you know, and say, you know, if you don't comply with these security policies, you're fired. You can't do that in an open source project, right? And we could probably argue till the cows come home about which is better and which is easier, but it's different. What we're trying to do at the moment, so Bluetooth solutions are a little bit further down the line. I think you all probably know that the Bluetooth solution without the Google and Apple protocols isn't working very well. You may also be aware that there's limitations on the Google and Apple protocol in terms of the number of apps per country that can use it, in terms of you can't use location data alongside Bluetooth in those apps. So our project's following two paths. The first path is what we're here to talk about today, and that's a GPS-based path. So people are often a little bit surprised about that, but the way we think about it is more like technology to assist human contact tracers. So if you think about what they're doing in the UK at the moment, where they have very manual-based contact tracers, they don't have any tools. You know, maybe they've got Google Maps or Google Street View pulled up in front of them and they're having a conversation. You can think of our solution a little bit as a memory aid and a communications framework to support that. So we hold data entirely on people's phones in a decentralized model. When somebody is diagnosed with COVID-19, they can then choose to consent to send their data to a human contact tracer. And we'll go into this in more detail, but we envisage they're on the phone to that human contact tracer. They're swapping an auth code at that point. The human contact tracer is then going through a redaction process. So yes, there's going to be false positives in there. Yes, there's going to be data that was incorrect. There's going to be stuff with someone walking through a park or a forest on their own, possibly going to Durham Castle on their own. Maybe that data needs to be removed before anything further happens to it. So at that point, once that data is then redacted, it is then to a degree anonymized through aggregation with other data. And it is then published back out so that undiagnosed patients can, if the health authority decides to publish a point of concern, can be notified that they were near a point of concern. That's really the core functionality and data flow. There's a couple of other things like giving people links to find out more information from their health authority. But I think that kind of sums it up. So where we are right now, so I do a lot of work with the British Computer Society, and some BCS contacts put me in touch with the London OWASP chapter lead. So we adopted OWASP pretty quickly within a testing framework perspective. Both Diarmid and I are from a general testing background as opposed to a expert security testing background. So we took some guidance, and that's why we've established those OWASP principles. For I think 90% of our security and privacy principles are kind of from the OWASP bit. Most of the stuff we put on top of that is about privacy, and we've got some pretty cool privacy features in there as well. So where we are right now, we've got those principles. The code is coming together. Tomorrow is feature complete. And I expect that some of the kind of big bugs that we've got are going to clear up between now and Monday. So next week, we'll be starting to move forward on doing more things like code analysis, pen testing, both dynamic stuff on mobile apps and looking at the web app. So just in terms of like help we need, you might hear me say, if you guys find a big vulnerability, don't be surprised if I ask you to come and fix it. This is really what the project is about. We're both volunteers working in our spare time. There's 100 people who are actively contributing to the project and have been for a few months in their spare time. We've got a few good security minds in the project, but it's not going to be enough to cover all the checks that we need to do and to review all the checks that have been done. So one more thing before I go into pulling up a diagram so we can start doing some threat modeling. One of the key points to understand is we provide a mobile app which is managed by the not-for-profit that has been spun off. So this project was originally set up by MIT and Ernst & Young, and it's now been spun off into a not-for-profit called PathCheck Inc., who will manage the mobile app side and will manage a central register of healthcare authorities that are allowed to use the app. But we give health authorities kind of a reference implementation. We don't manage the infrastructure at the back end. So many of the principles that we might want to say, like you should have layer 7 firewall on anything exposed to the public, you must use TLS 1.2. We can't actually do that for them. We can only make that as a recommendation in a deployment guide and outline the risks of not doing that. And we also, as you were kind of alluding to, Dennis, before, we kind of, the healthcare authority side of things is a semi-trusted part of the infrastructure. I'm less worried from a security perspective, but more from a privacy perspective in terms of how we control what they do with the data. We've done a few things to try and restrict what they can do, but that is a risk and probably one of our lower priority threats.
Quick question on that,
Sure.
Adam. Just as we're going along, have you used anything like the language defined in RFC 2119, so must, should, may? Have you used that in your construction of recommendations for health authorities?
No. So we haven't actually, at the moment we've got READMEs coming out of the developers. And when we go through all the different OWASP verification checks, we're going to hit things that it's like TLS 1.2. So then I'm going to go and look at the README and say, is that in that normative language that you're using there described in there? But I think it's going to always be you should, i.e. it is recommended to, because you must implies that we're going to come and bash the door down if they don't. And some of these healthcare authorities, they're not going to have a huge IT team, a huge IT infrastructure. It might be quite a small country. It might be a developing country. So we're not going to prevent people from using it based on their kind of DMZ setup.
Right. Okay. So,
I'll just say a little bit more to that. I mean, it is a topic we're actively engaged with, and it's not just about privacy and security policies, but also about ethical policies. It's a very difficult question as to what do you do when you want to go to a country somewhere across the world and deploy this technology with them, but they don't see eye to eye with you in terms of some ethical aspects of this, and it's a topic of active discussion about when would we draw the line, at what point would we say no, we're not going to work with you on this.
well, no, of course, because there's plenty of countries where you don't have TLS 1.2 on devices because they're using Android 4.
Right, but it goes to right to maybe they say they're not going to follow our redaction guidelines and they are going to include people's home addresses in the data they publish. At what point do we say no, we're not going to work with you? Particularly bearing in mind that the consequences of us saying no, we're not going to work with you might be that they choose to deploy some other technology which is even less privacy protective. So it's an active topic of conversation. I think I just wanted to pick into Adam's point of we would never say no. I don't think quite right. There are some circumstances in which we say no, but it's a delicate balance, and it very much gets into the kind of high-level ethics of the whole project rather than being a specific security or privacy issue.
Thanks, David.
Do you have a diagram for what saying no actually means?
No, we don't, actually. So as I understand it, we have a centralized YAML file that's published somewhere. And if a healthcare authority isn't in that file, you can't send data to them through our infrastructure, through the app specifically.
But you're the one saying that they're going to deploy their own infrastructure.
Yeah, we do have a diagram, I think, that maybe shows this. So we have there's a piece of infrastructure from PathCheck, which we own and run, which is effectively a very, it just consists of a registry of these are the health authorities that are valid within our ecosystem. So we don't store any patient data or anything like that within that. But that's what the app goes to when it when basically you say, well, which health authorities do you want to register with? Which do you want to send the data to? It gets that data from us, and then then that initiates the communications with the health authority. The whole thing's open source though, so for somebody to take the app and modify that bit of code so that it points to a different server, etc., is again entirely possible thing to do. So again, that's where it's hard for us to give a hard no, because they can just fork the repo and go do what they want to do.
But that was going to be my point. My point here is that I think you have to embrace the fact that you open source, right? You have to embrace the fact that, from a security point of view, right? There's a number of things I was reading that you had these kind of comments which were like, we're making it really hard, we're making this kind of possible, right? I feel that it's very important to understand what is a real security measure. And Microsoft had this really dodgy definition called a sand dune, right, versus a sandbox, right? What is these little things that it was when they pushed the, if you remember the user access control thing in Windows, where they were supposed to prevent malicious code from running outside your process, and the more people kept breaking stuff and finding holes, eventually they go, well, this is sand dune, right? It's just there to prevent, bad actors. But look, it's very valuable. I'm not saying it's a bad thing, but I feel on cases like this, you almost have to embrace the fact that you don't control that, right? Yeah, I think you have to embrace the fact that, for example, like when you're saying that you have a central authority, right, to control the registrar, first threat, in fact, Tatvik and stuff like that, I'll work with you a bit later, but this is a good example of an asset. You just created a massive asset, right? And you create a single point of failure for the whole thing, right? Because if that gets compromised, and that's one of the models, right? One of the models is what happens if your central authority gets compromised, right? And the thing about this, especially on, I would say, on an app like this that gets used by multiple countries, and I actually think that you need to think a bit bigger than that. I think companies will want to use this. Like, I want to use this, my company, right? Like, we were having this question initially. We actually almost thought about designing it, because in early days of this, we were thinking of, look, the office will be compromised. We know that. We know that people will be infected, but let's at least have a sense of, how dangerous it is. We initially were tracking the logic of, do you know somebody who knows somebody who's being infected? Like, do we know how far away are we from the freaking, wave hitting you? So I think that as a company, I would want to have this, right? I want to, this is good enough, but in this case, we will run on our infrastructure, right? So this is a good example of an asset that needs to be well thought through. And I feel that the other thing I would already say is that I don't think you should shy away from pushing secure solutions. What we know is that the biggest power you have is to push a secure default, right? And what we shouldn't be doing is almost again, I would say the Microsoft and now the AWS shared responsibility model, where you define, oh, I do all these things here, and then I allow you to shoot yourself in the foot in all these different ways, but it's going to be your fault because you've done that, right? I think in this case, you shouldn't shy away from knowing that you will be pushing. In fact, you probably need to push 2 or 3 reference implementations. One super secure, one more relaxed, one completely open. But the bottom line, like you said, your fully open is probably better than every others, right? that are closed, right? So, and remember that you won't control what people do with this. That's the big lesson I've learned designing APIs and designing systems, is the creativity of your users will even be more insane than the creativity of your attackers, right? So you won't control who uses this. But
there's there's also a thing. So I did some quite a bit of research on the privacy, the private kit that is kind of sitting behind some of this. And I actually reached out to the MIT Media Lab people, Abhishad Singh should be praised. He's been emailing me. He's one of the named authors. I reached out to him. He's been emailing me, and we've been having a brief conversation about sort of what are the cryptography requirements from private kit's point of view, utilization. And this kind of feeds into that. So they actually recommend the fully homomorphic encryption, the FHE method, the method 4, as being the method that you use. And they've said that the others have some issues. some of them typographical, which I've raised, and I've offered to help fix that. So that sort of, there is something we were talking about, fidelity of implementation documentation to actual code, and I'm thinking, well, that's hard to do if the documentation is already like not necessarily in agreement as to what it means. So I've offered to help out with that. But yeah, so they've said that's their recommendation from MIT's view, which we then have to temper if we're then going to, because that won't work, as you pointed out, Diarmid. That won't work if you have a device that physically can't do that cryptography, or finds it very hard or intensive, or there's no point doing it if it's going to drain the battery of every phone when it's deployed in so sub-Saharan Africa or Latin America, where the latest Android smartphone is not the de facto standard. You can't use a secure enclave. It's hard to do some of these things. It's hard to do proof of work and that kind of thing, because the batteries are not ever fixed or changed. So it's just a consideration that if you haven't used the must, should, have, may stuff, that kind of works for you because it makes you very flexible. But it also means that you have to prepare, as Dinis is saying, for people to get creative with their solutions and to try and sort of steer them towards use the best that you can, rather than, sort of, if you can't do this, then you should choose one of these options here. So that's just a little aside that's deeply technical.
Yeah, I think my point on, or my response to the must, should, may advice is that it's excellent advice, and probably the main reason why we can't say yes to it yet is because the documentation is not even at a sufficiently draft stage yet to use or not use those words. It's very much still under development.
I only mentioned IRC 2119 because it's what I use in my documentation. I know a lot of other people do, so it's kind of, people will know exactly what you mean.
No, absolutely. I completely agree with the recommendation. I'm very sure we'll adopt it as soon as the documentation is in a state that has that level of formality about it.
But we need to test it, right? So I'll give you an example, right? So if you look at the way these days we think about kernels and about operating systems and how things develop, we have secure hashes for certain parts of code, right? So I will argue that there's parts of your code that nobody should be touching, right? Like there's parts of your code that, like cryptography is a good example, right? Like, come on, if you want to freaking change the cryptography of this app, you do it at the central. We do it, people that are experts, you do it, with the good consideration. You don't go mock about that part of the code. So, there's a chunk of your code. And remember, this is open source, but we can do things with open source, right? We can validate things, but also we can give toolkits for the independent players at the receiving countries, for example, to validate that stuff, right? Because, let's say I'm Portuguese, right? So the Portuguese government could decide to adopt this, but they should now get the Portuguese security team. So we have some great hackers and some great security research in Portugal. And actually they should have the mandate to verify and to double check that whatever the team in the government that decide to implement that haven't shoot themselves in the foot. And this is where the risks become interesting, because you can argue that a government or a company that adopts this without that verification module connected to it shouldn't be trustworthy, right? And this is where this game is quite interesting. Right? Because imagine you have 4 countries, right? They go from a spectrum of the ones on the left, they adopt it, they make a bunch of changes, they use independent, they invite you guys to collaborate. Yeah, or maybe they use your out of the box, right? The next crowd, they made a bunch of changes, but they use the same practices, they fork everything because, for legal requirements, like Switzerland, man. Dude, there's no way you can get the Switzerland data out of there, right? Like literally, it's probably not going to happen, right? And probably even in other places. In fact, these days with GDPR, right? So they might decide that they want to run it independently, right? And they probably should, but they want public verification, right? So, almost like if you give them the toolkit, if you give them the use cases, you give them the test suite that goes into their pipeline, then you have the level of assurance, not just today, but tomorrow, right? And when you push a fix, that, you're not, introducing these changes, right? Or if you need to push a fix to your cryptography, that, hey, most of these implementations, you guys should just apply it because, you shouldn't be mucking about with this. And if you are, means that we should have a test that should have been modified to confirm your changes.
The only place I can think that we have any kind of key that we're keeping out of the open source repo that I'm aware of is the keys used to sign the apps before they go into the app stores. Mm-hmm. That's the only thing I can think of. Shall I, Dinis, I know we want to do threat models by feature. Shall I just bring up a quick diagram of like the high level first? Yes. So then we can kind of identify the different areas we want to deep dive into.
Yeah.
Cool.
While you do that, can I just ask a question, right? So you did speak about it before with the flow when someone sends their data to the people that need to analyze it. So is that data then published? The data showing like location and stuff.
Sort of. There's a number of protections we've got around that, like geohashing and the one-way hash that Diarmid was talking about. So I think that's one thing we can deep dive. I think that's one thing we should definitely deep dive into.
Yeah, because one thing that I've seen with apps that do make this information public, even when it's anonymous, it can often highlight kind of areas of interest, right? So sometimes you'll see on a map, okay, so lots of people are kind of moving around this strange area in the desert, and actually you realize that's probably some kind of secret building that is now kind of known about because you have this GPS location that's showing it.
So that's where. So that's just to answer your question, Jay. That's where there's the use of private kit comes in, specifically method 4 in a document I'll put in the chat. I think it's already out there, but I'll just put it in the chat so people know what the hell I'm going on about. There, I think that's page, what is it, 5 or 6? 1, 2, 3, 4, 5. Yeah, from page 5 is method 4, which is what they're recommending as the default. It's called Palisade. So that's all been handled academically and is all kind of coded up by MIT, I think, or related parties. So that's kind of lifted out there. I had questions that was about that, and I think, and I've offered to sort of help out and engage with them to spruce up some of the documentation, because there's a few niggles that I'm like, mathematically that's not a thing, but I get what they're getting at, and I think what they're saying is generally fine there. So with respect to the privacy of sharing location data, the reliance, as I understand it, and feel free, Adam and Emma, to correct me, but the reliance is on that cryptography to actually secure the anonymity or the privacy of that particular flow, or not. I don't know.
I'm not sure I'd put it quite that way. So I mean, first of all, I mean, the fully homomorphic encryption stuff is a design concept at the moment. That code does not yet exist. The Palisade library exists, but there's no implementation on top of that code. And we've got various questions about how we do want to implement the architecture. And that paper talks about 2 servers. We're not sure whether we might want to actually implement what's logically described as the server 1 function and try to implement that on the user's phone, because that enables us to retain the principle that your data does not leave your phone, which we think is a strong message that will resonate with users in terms of privacy, versus the data is encrypted with a key that we have, and you send it to us and we promise we won't look at it, is sort of less powerful.
Very much so.
Raises all sorts of questions about, well, how do we know that the server 1 and the server 2 are separated, etc. So what we have in the meantime, which is coded and implemented, but is not, probably if you've downloaded the app, won't be in the version that you've got in the App Store right now, is that we use we basically hash that data with a slow hash function, which makes it relatively expensive to
script, that's right.
We use script, yeah. Relatively expensive to decrypt the data, and in particular, if you want to comb the desert, so to speak, hundreds of square kilometers of desert, then that I think would be very expensive to do. On the other hand, if you want to know whether a particular cafe or bakery or whatever has been infected over a period of a couple of weeks, that's pretty much analogous to what the phone is trying to do, and therefore that we can't afford to make that expensive. So
pretty expensive in the UK was $4,000 or something like that for the space of America, if I remember.
That was for what did I come to? That was for 3,000 square kilometers for a week, I think, or 2 weeks maybe. So I don't know if you think that's expensive or not.
It depends on the business model of who's making the money, right?
Yeah, it depends on I mean, if it's the national government and they want this information for some reason, then of course it's it's peanuts. If it's some curious citizen who wanting to blog about it, it's probably enough of a deterrent. So it's for sure it's a sand dune, not a sandbox. and we're trying to be completely open about it. Fundamentally, the privacy that we afford to individual users fundamentally comes from the fact that they're redacting the data. We've got to make sure we have clear policies for the health authority, clear privacy training for them on what data they should be redacting, because we don't expect every user to necessarily know, or spot all of the risks. And so it's really about making sure that after redaction, all of the data that's shared is data that, if it did become public, would not be, would not be a privacy concern. It's really just a list of what you end up by that point is a list of the places that they've been and the times that they were there over a period of time. Those all then get mixed together so that you can't, associate them together. That's the theory, and obviously, happy to hear.
I think this is a great workflow to one of the first diagrams. Do you have this is the one, right, where you got the data flow diagram of actually how that thing works? And by the way, my first instinct is I think you need to introduce the concept of independent data providers and who are trusted, who have one job in life, which is to anonymize the data. That's just my first instinct, right? But I think if you don't introduce a third-party service that can be trusted, right, or not, right, that's up to the other side, right? But to provide those checks, I don't think your health care providers are anyway even qualified to even have that conversation, right? To
somehow algorithmically process the published data set for a user and say whether that's sufficiently anonymous.
I feel that, look, you probably need something like a service that should be trusted, have very strong guidelines, ideally, again, a public service that, the job is to take the data, apply a bunch of rules from the user, probably double check with the user, is this what you want? And then send it downstream.
Would this be where constructing some kind of container or kind of Kubernetes instance which can be shared?
Well, here's the problem, right? So you don't want to, you need to maintain the data points where the contact tracer believes that points are of concern. You don't want to lose that data through anonymization.
I see.
You want to aggregate it with other infected users' data, so effectively differential privacy. So it really is a healthcare decision. There's policies and processes in place, but we need to make sure that's
but the example here, right, is that if you look at every individual, because the point is that the data will leave your service, right? Like the data will leave your phone. Let's be clear, right? Like I think there's a guy yesterday, I like the guy who said, look, this is a contract tracing application, right? There's no way you can get around the idea that we are tracing your steps, right? Like that's the point of the app, right? So, but if you look at it from a privacy point of view, and I love Bruce Schneider's definition of privacy is, or Seth got it, so I can remember, is when you are surprised. The lack of privacy is when you're surprised at what happens, right? So if you tell me that you're sharing the data that I go over my commutes, then I have a level of expectation that's what I'm okay with that, versus you're going to share every single place I went to. So the Durham Castle example, we need to allow that individual to remove that from its data, right? That's, and I think that's one of your principles, right? It's like you want to put the user in charge of what he shares.
At the moment, the user discusses it with the contact tracer and explicitly consents to it at the end of the contact tracing interview. So there's like a process control. We have a future goal of trying to display that data on the diagnosed patient's phone so they can validate with their eyes what's been actually redacted.
And just a discussion about whether that process should be a user-driven process in the first place, so that you can redact where your location data in advance of advance of sharing it with anybody other than you. But again, that's not something we have right now. The redaction technology is driven by the health authority acting on a complete data set, except for the fact the user does have the opportunity to turn location tracking off at any point in time. So if you're about to go on a protest or whatever, something that you might, because if you remember to, you can turn the location tracking off at that point. If you didn't remember to, we don't currently have a mechanism where you can remove it prior to sharing before asking the health authority to remove it for you. And that I think I see that as a gap. How important it is versus other gaps, I don't know.
But this is where we need now to start mapping this. So the way I look at it, that's a risk, right? So the user is not able to make able to visually see what he's sharing, right? And in fact, the user is sending, right, all his data, right, to the health authority. I don't know, correct me if I'm wrong, but That's my understanding at the moment, i.e. where he's been to.
All the data is collected, yes.
Yes, and and this is a good example, right? That this is a risk, right? Now, this is where, like you said, whether this becomes a priority now, whether this becomes a priority, in 6 months from now, where does this follow? My view on this is that we need to acknowledge this information on the model that you have, right? Because it's a risk that at the moment, the user is not able to control that.
Completely agree.
Right.
And I think that area is an area we need to consider, because the user's phone, this user's phone, the healthy member of the public, that really is a sandbox, or it should be a sandbox, not a sand dune, in that,
yes.
We shouldn't be able to pick up lots of people jogging around a military base in the desert, because it's only once someone who's been infected, so a small proportion of the users, where data will be transmitted across. And that's absolutely crucial to our solution.
So one question I have with this, so walk me through. So the infection patient, me, right? I walk around, this thing is grabbing every 5 minutes, is basically creating a secure, hash of where I've been to, right? So it's capturing my geographic location, right? So let's even think about this without an encryption, right? Let's just think of from a data flow point of view, right? Actually, do you have that flow somewhere? That literally just follows the data points?
I think we've got a good documented flow for what happens at the different stages of upload when someone gets diagnosed around here.
Yeah.
But it's not a diagram.
Okay. So, all right. So maybe that's something that we can work on. So if I walk you through my understanding, you can correct me, right? If the bits I get wrong.
Yeah.
So as a user, I got a mobile phone, right? And I install the app, and this app is running in the background 24/7, right? As a service. Mm-hmm. Right? And this app every 5 minutes is basically restoring my GPS coordinates of where I am from the phone.
Yes.
Correct? So I got a nice list, right? And basically timestamp, right? This date, this time here, this time, whatever, right? This is just geographic coordination, right? Which, by the way, is what Google's already doing to me, right? Because, I can go to Google, I can track my history, and it shows exactly where I've been, right? So, there's a feature. I don't know if you've seen the Google, whatever it's called, history or Google thing. If you do that, it tells you all the places you've been, right? So that captures that, right? So then, at the moment in time, I go, okay, I think I've been diagnosed. I've been confirmed. I have, the virus, right? And then I call somebody, right? I contact my, your health authority, and I talk to them. Or in fact, maybe when I'm part of the in a hospital, or when I'm involved, they go, hey, do you have the app? Do you want to share your data? That's kind of the flow.
That's right.
Right. And then they go, cool. And I say, yes, right? Because probably I would, right? And I said, okay, I want others to understand, so you can trace this, right? And then I upload, I'll basically press a button, somebody up, and then that sends all that data to a server.
There's an auth step in there where the contact tracer gives a code word to the person who's infected that allows them to upload the data. And that is so we don't get spammed with fake data.
So the health authority goes to, or gives, well, ideally key, right? Goes to their system, adds the word, right? And then gives the word back to the, so well, they have an app, right, too? Is that how it works?
Yes, so this healthcare authority has their web app in front of them, and they essentially create a case, and then they're given a code word like Bluebird, or I think it will actually be numeric, so that it works in more countries successively.
All right,
and
how many numbers?
I can't remember. Let me see if I can pull up this detailed flow.
I think it's a 6-digit code right now.
How much?
I think it's it is 6 digits.
What if somebody brute forces it?
Yeah.
There's been a bunch of conversations about that. I can't remember what the specific answers are certainly something we've considered. Whether we got the right answer out of that consideration, I don't know.
For reference, this is something that I've done some experimentation on with most modern sort of setups. You can brute force a 5 or 6 digit key space in about 24 hours to 48 hours.
So that would allow you to put in one piece of fake data every 24 to 48
Would allow you
hours,
to
right?
initiate a conversation with a contact tracer about your set of data, which would probably fairly quickly from that conversation become clear that they were not looking at the same set of data that you were. So I think it's those kinds of considerations that has led us to thinking that 6 digits is enough protection there.
And look, this is where, security, I think sometimes is important to be rational, right? You could have a 4-digit that is okay. For example, if you detect very easily any kind of exploits, right? Because, okay, I wouldn't put the 4-digit, I'll put probably 6, but, or whatever, 8. But this is a good example of if somebody is brute forcing a system, will you detect it? And I'll be more worried that you're not able to detect, 5 billion or whatever, 10 gazillion requests, required to brute force that, than the fact that they just happen to hit on that one.
Yeah, there's some rate limit you talked about in the design as well. I remember that in the discussion about the entropy for that. Because I mean, the concern is, 16 digits or whatever gives you loads more entropy and more protection that way, but much more kind of errors in terms of people failing to enter the right codes and
I agree.
those kinds of things.
Yeah, and I think security is very important to have that balance, right? And in fact, it's probably, if you look at Bluetooth, right? You get a key, you put in, right? It's sometimes it's a good balance, right, between one system and the other, right? So, all right, so the health authority goes and puts the key in the system. You probably can generate that ID, right, for them, or do they put in themselves?
So it's generated by the back end.
Cool. Yep. And then the user types in that ID and then uses to upload the data, right?
Yes. So the phone and the server don't know each other. So the phone has to post the access code to a service that allows it to be validated.
Mm-hmm. Yeah, but I think at the moment in time, so the only ID that you have for the user at the moment in time is that number.
Yeah, and it only exists in the database until it's been confirmed.
Yeah, so this is where, so for example, like you one of the interesting things here, and this is probably a risk that you have to accept by design, is that you, how do you tie, you cannot tie that to an individual, right?
Yes, correct. That is a good thing, though. We're kind of avoiding that link between an individual and the data in our system that we're deploying. That said, the contact tracer, they may choose to use the case ID from our system to write on the medical records. They may establish that link in another way, and that's difficult for us to control.
Yeah, but that's so now you see. So that's a good example of a risk. That sorry, a second.
I would actually say it's good that the data is not connected, so that the owner of the system, the developer or the database owner, they cannot connect the particular person with their GPS data. Mm-hmm. So it's actually the opposite. It would be a risk if it was possible.
Agreed, but then that I think that feeds into us needing to provide clear guidance for the health authorities to say, do not take this number and write it in the patient's medical file, for example. They should not, or maybe even must not, but probably should not be storing that anywhere, in any other system.
But you see, but now, and this is like. And where it gets interesting, right? Because when you look at now, this is where we start to map the threats, right, of this. And by the way, like we'll create some diagrams out of this, right? So we can have this kind of more free flow conversation that we try to map it better later. Is that there's times in security where you don't cover all the cases. Like I'll give you a very good example, right? When you have a login system, if you allow users to type multiple passwords, right? In big sequence of events, you have a brute forcing problem, right? I can brute force username and password. If you block after 5 attempts, you have a denial of service problem, right? And actually, there's other things you can try to do, but some of these things you can't move away from, right? So this is a good example of the fact that you can determine a strong identity of who provided that, right? And by the way, by strong identity, I don't mean that you might even know who the user is. But at the moment, my understanding is that the only thing that you have to pin to a particular set of data that you've got is an ID that was created by a health authority.
And it's immediately discarded.
And it's immediately discarded, right? But that means, so the risk now here is that the integrity of your data is now at risk, right? Because the quality of your data, that means that one rogue health authority person can generate bazillions of bad data into your system. Or one hacked health authority. So you have to assume that your health authority computer could be hacked, right? Could be under somebody else's control, could have a Chrome extension that is malicious, right? That they installed, right? Could be misbehaving. Or in fact, you could have, you could allow, all your players, right, to create this. And yeah.
I don't think that's how I think it would be easier than that. A rogue HA employee, because we want to support people who don't have a mobile phone or didn't have it on them at a particular point in time, the contact tracer can manually enter longitude, latitude points of concern into the data. So they could theoretically, when talking to someone, add in an extra point without the person they were interviewing realize that. For malicious purposes. That would be the easiest way for a rogue HA employee to enter bad data.
Yep.
Do you have a way to delete the data after finding out the particular HA employee was malicious?
Yes. Or if a diagnosed patient calls up and says, I confirmed I was at that place, actually I wasn't.
I'm not sure that we would be able to pull out one particular health authority employee's data offerings from the mass of all of them, because I think they once they're published, they just all agglomerated together. We can't tell which contact tracer has generated which data set.
So
I'll have to check that. I thought we could.
So one pattern, right? And so that's interesting, right? Because, and by the way, so one of the things that we also try to do here is the key concepts is facts, vulnerabilities, and risks. So maybe should I explain this? So facts is things that we know are factually correct, are factually true, right? That's the point, right? A fact, and the fact could be that we don't do something, right? A fact could be we don't know that, or that's not acceptable, or that's not something that we can do, or X, Y, Z, right? A vulnerability is kind of a fact that has security implications, right? It's sort of like the vulnerability should still be proven, right? Or else it's just, something you throw over the fence, right? So a vulnerability should be kind of something that has security implications, right? So for example, the health data can be modified. Like I say, the health practitioner can add a new entry point, right? That's a vulnerability. It's still a fact, but it's a vulnerability. They can do that, right? Now the risks should be the side effects of that. It's almost like the 5 whys. Why does that matter? And then you ask, why does that matter? Why does that matter? Eventually you get a nice tree that for example, like one of the trees should be a rogue health agent can cause a number of damage, right? That's a risk caused by rogue health agents that you need to think about as you go to a distributed system, that there's lots of players that can game the system, either by incompetence, by malice, by mistake, or by their own business models, right? You have to take that into account. Right, and the other element to think about this, which for me is massive in social environments, is that the name of the game is to assume that data will be bad and somebody will do something they're not supposed to do. Our job is to pick it up. So our job is to make the data make a mistake, right? To make the attacker make a mistake, and then we pick it up. So I'll give you a good example, right? If that health provider creates an impossible jump based on the other data, that should be picked up, right? So if I'm telling you that, okay, I've done here, I was in West London, I've done this stuff, etc., and this is my 30 data points, but if I go, oh, by the way, I also went to Leeds, I also popped to Portugal while I was doing that, right? Like, that entry should almost not be possible to be entered, right? Or put it this way, at the moment somebody can do it, but that's the kind of stuff that you want to pick up from a malicious point of view. Because the reality is that there's going to be a reason why that person wants to put a new entry in, right? There has to be a reason, you know, why would they do it? And that reason might be connected by commercial, by revenge, by manipulating the data, etc. If you game the system so that they can only introduce changes that are consistent with your pattern, you dramatically reduce the attack surface. You dramatically reduce, right, the ability to introduce bad data into your system.
How are the notifications, the workflow for the notifications? Is there any steps in, I'm just thinking about how you would actually like sort of weaponize this particular threat in a way that's going to be like useful. Suppose I'm a criminal and I want to, I don't know, break into a shop or, you know, sort of get a tracked on an ATM without anyone seeing me. I might want to raise a notification for everyone in a particular area. Oh, you got to stay inside. You might have COVID. So how is the notifications generated? Because if they're generated automatically, that's where you might have.
So we have a contact tracer, and we expect it to be a lead contact tracer. So the publishing step, so we don't actually give a reference architecture. That might be an S3 bucket. It might be a web server the health authority owns. And we're expecting there to be some kind of review process, but we're not providing functionality to directly support that. Okay. Just thinking about how it could be exploited, I was just thinking then, if a code is created and a contact tracer has someone on the phone who puts that, gives them the code, puts it in the app, then I'm wondering whether that code is actually end of life immediately or end of life within, you know, if there's a few minutes window, when as a contact tracer, I can send a curl in my terminal with that code and a large payload of data. But the control on that, I think, is the human review, which we can't enforce.
So that's a really cool one for us to maybe start looking at, right? Which is that exact sequence of events, including what it does look right in the code, right? Because basically what you're saying is that, you know, when we look at the code, you know, the question is, when does the token disappear, right? When does that unique ID disappear from the system, right? Is it straight away, or is it, you know, after 2 minutes? But again, from an attacker point of view, that means that I can now upload, you know, tons and tons and tons of data in that period.
It's a matter of looking, usually with codes, it's a matter of, at least in my experience, it's a matter of looking at the different ways in which you can kind of rate limit both in time, in the number of times the code can be entered. So if someone incorrectly enters a code 5 times, then they get issued a new code, for example, because that's one way. That's another way of mitigating sort of brute forcing. There you start relying on things like the birthday paradox. You can still hack it by making the same random guesses each time, and you will eventually be right. But if you then layer on rate limiting and also time-based limiting as well, so if you've entered so many codes, then you've got to wait so many seconds because, you know, you're clearly doing something that is wrong, and you either might need a hand, and you might need to call someone because, you know, you're elderly and you're not entering it right, and it's not making sense to you or something. So at that point, you might say, would you like to call someone and, you know, deal with it that way? Or it could be that you're, you know, sort of a bad actor. This is the issue, isn't it? Like, someone having a major error is not, it can look the same as someone who's trying to sort of break something, or misbehave. And Dinis alluded to this earlier.
Is it you guys who try to do some statistical analysis on the data when you aggregate it to pick up outliers?
This is for the threat of, we're concerned about the threat of a rogue health authority person or somebody external to the system feeding bad data in, or both?
Well, you have to remember that this whole system is based on you receiving data from people you don't trust.
Mm-hmm.
What if one person submits like a lot of data that they've been to every place in the country during the last 2 weeks?
So no data that's so all the data goes through human review by a contact tracer before publishing. So I think the exposure is much greater for the rogue contact tracer than it is for a person who's external to the system who's trying to feed raw data in.
How does that work? There's the UI for the contact tracer to show them all of that?
Yes, so they have they have a map basically. Think about, Google Maps screen with a lot of dots and waypoints and things like that. So that's very visual.
Yeah.
And they can delete groups of dots, they can delete individual dots, etc.
So who received that? That's another contact tracer. That's not the one that has given the code to the infected user.
It is the same person. So they will create a case, they'll give a code. Once the code's been typed in on the mobile device and the data is exchanged, it will display on the screen.
So there is a link between the special code and the user and its data. There is a connection, right? Because there is a case.
Yes, but that access code itself is not maintained.
Yeah, I think maybe tomorrow, what we can do would be great if you actually show this working, right? Actually, those multiple web apps. There's the bits where you guys are there, right? And actually, look, this is an interesting case, right? Like, and look, I'm a big fan of inefficient sometimes systems that give you a lot of security, right? Like for example, like the fact that you now have a human looking, right, at the data before it gets submitted, right? It is a good thing, right? It's actually a security measure on the system. So the same way that introduced attack vector, it also prevents, right, a lot of number of attacks from occurring into the system. The problem you have, and this is why it's so important that when we make the tree of this, that we capture that on the fact, right? What's it called? The manual verification is that this is something that will change in the future of this app. I guarantee you, right? You're going to get a feature request to ingest those things automatically because there's a moment in time where this won't scale, right? And actually, I'm also thinking there's a case where you do want the same individual to keep submitting the data, right? So if you think about it, what happens tomorrow? What happens in a week from now? Like I know you say, I'm supposed to be self-isolating myself, but what happens if that person can't, right? What happens if that person is traveling somewhere else, right? What happens if that person had to go to hospital, right? For all sorts of reasons.
I think that's right. I think this refers back to the point that Jakob was raising earlier, which is that if you have deniability about the data that you're submitting, then that is a privacy enhancement because you're not then tying an individual definitely to a particular place. So I think you're touching on a very core point there, Dinis, which is like, so how do you actually sort of validate things and how do you actually then utilize that data once you've actually sort of received it and then verify it to the point that you're happy it's an authentic data point, but still preserve the fact that it might be something from someone who maybe wants to plant false data. It's an interesting problem.
But that's the real world challenges and balance on this, right? And I think by acknowledging that, you acknowledge reality, right? There's nothing wrong, by listing all that stuff, because the bottom line is that is the ones who don't acknowledge this who probably are doing a worse job, right? So I think in this case, we're basically saying that the health authority individual, which is why I was saying that my instinct is that you probably need a trusted party, which could be, that contract tracing team, right? Maybe that's just the sole job, what you guys have is the contract tracing team, right? To do that. My only concern is that becomes, it's quite specialized skill, right? And I think, they probably need, and those individuals need to do a bunch of other things, right? While they talking to the individual and support them and, all sorts of guidance. And my only concern is that, we're putting a lot of pressure, a lot of requirements into somebody who's already going to be super stressed, who already has 10 other things to do, right? And rely them as the guardian, right? Of both the data coming in, right, and the quality of that data, could cause blind spots. On the other hand,
there's an interesting chat, a question that just came up in the chat, which is kind of relating into this again from Philip, where can this be used to track people? Well, this is kind of like in one way, as Dinis said earlier, this is kind of the idea that you are tracing where you've been as a user, and then marrying that up with known infection information. Like you are, by using and utilizing an app in that way, you are sacrificing knowledge of where at least one person has been. And all of the cryptography and all of the privacy stuff that we're talking about and all of the protections are to maintain the integrity of that data as much as possible without leading to compromise of an individual by saying that this is their route to work and this is sort of what they do. It's like sort of looking at those running tracing apps, where you can see where everyone's been running. The idea is that you can see where popular routes are, or using Google Maps, you can see where busy roads are without knowing who's making the road busy. So I think this is the balancing that we're trying to do, and this is the thing that is really sort of where all these discussions lie in. You want to be able to avoid abusing that functionality whilst also maintaining fidelity of the data, just to sort of come in and answer where Phyllis is probably
I think that's right. And I think one thing, given that, we need to be one place where we shouldn't be making trade-offs and where we shouldn't be using sand dunes is really what's running on an app for someone who's not been diagnosed, because that's the worst case scenario, is we enable the tracking of people who have not been diagnosed with COVID, and those trade-offs aren't applicable.
That's a really good point, because I think when we do a pen test, right, and that's really cool, because what you just described, right, it's a very nice tight brief for the client app, right? And basically the client app should just be pulled, right? Should just receive data, but also the client app has to protect itself from the other client apps running on the same machine, right? So it's a good example of that app at that moment in time should do, make sure that, where it stores. I know a typical, I'm hoping it's not doing that, but a good example is there's apps sometimes who store data in places that gets, easily, discovered by other apps. And there's now good places in the OSs, depending on, again, which OS your version, where you can actually store data that becomes really, really hard to access, right? Even if you jailbreak the phone, or even if you kind of, start to do that kind of stuff, right? Because I think that would be quite powerful. Because I feel that there's a really cool piece of work to be done here on anonymizing data, because if you look at it, right, it's almost like we need to pen test the data, right? So it's almost like you need to separate these bits, right? So we now said that you take the data, you go to the health tracing application, okay, tracing provider, which is, that intermediate representation, cool, right? Their job is to send the data upstream, right? In a way, their job is to say, okay, I'm now sending the data to my data lake, right? Over there, right?
Yeah.
And I think there's probably a really cool piece of work to be done in making sure that the data lake is anonymized, right? Because if you think about it, like a lot of those things will be corner cases, right? So you can even say that if you don't have enough data points about a system, we don't store it, or you take it off the data that goes out, because that's the data that you share with everybody, correct? So that graph, which is who went where and what's the connection, is actually the one that gets shared. And look, there's a case where you can even just share by region, right? Like, look, the conversation, Mark, I was kind of going on Monday, what I was trying to say, like, do we even have data to support, right, that this thing actually works individual to individual? Where I feel that we're making tons of decisions today that affect society without even understanding with any data, right? So, do you need to lock down London or West London or Chiswick, right? Or, which where I live, or, or Durham, or Cornwall, right? Like, I have a friend of mine is now living in Croatia. I say, hey, this is great, man. I left London and everything is normal here, right? So, I think even if you take a first step and say, even just having the data by postcode, right? Or even having the data by a wider area, what it allows you to understand is, as we isolate areas, right? And as we isolate parts of society, how many degrees of separation are you away from an infection? And that's already valuable in itself, right? If you think about it, you can make very good policy decisions just based on that data, which I think you already have, right? You will collect that data. And what I like about it is that, which is something I think, I was kind of raising with Mark on Monday, is that I'm really worried about a system that you need 20 to 50% coverage to be effective, right? I had very good success with lots of equivalent systems that you only need a very small percentage of the population to be able to already pick up a lot of things, because they are already your canaries on the coal mine, right? They're already telling you something is happening here, because at the moment, without that, we have zero data. Like, without that, think about it, like we get no information about where people are and where they've been to, and how, do you have the super spreader that just crossed the whole freaking country, right? versus, some cases that happen in one place.
That's the nice thing about this particular structure that I like, which is that you've kind of tiled the UK. And I like it for two reasons. One, it means that you immediately get a heat map, and two, my PhD in maths is actually on tiling problems. But yeah, so you automatically get a heat map, which you can actually utilize to measure the kind of the heat gradient of COVID-19 across the UK. Like in London now, it seems to be much less prevalent than it was in the middle of April. Whereas you're still having sort of issues in particular areas. So the potential for health authorities to have really good data from a relatively small contributing set is quite high, because you can relativize it based on population densities and do some nice data science on that information. And the key really is keeping it that, sort of people become these data points, and then they can look up where people can look up where they've been, and then are they potentially at risk, and kind of do all that marrying up. So I like the approach. I think it's got a lot of legs. I think that
because here's the question, right? If you said for the first version of the app, right? Let's just evolve this, right? For the first version of the app, you actually go to that wide, like from a publishing point of view. See, this is almost quite interesting, right? You almost want to capture as close as you can from a point of view, but you want to publish as wide as you can. So if you said that the first version of the app, the anonymization process, it's about basically saying that we won't share more than, it's a mile radius, right? Or, a postcode radius even, right? Or whatever, it's a wide thing, right? And you just literally, it's like the tile thing, right? You just color coding, right? And you just say how many cases and how many things you got within those tiles. What you've done was you dramatically reduce the attack surface of the application, right? Like you basically, it's almost like we're tilting the odds to our favor, right? Because we're basically saying at the moment, we don't have to defend against those outliers, because, and actually then it's easy to even pick up those outliers. We can say, look, around these military bases and around these places here and around those things there, we won't put data in, right? In fact, I'm pretty sure there's already mapped data on that one, whereas the places in the UK that you can't, do stuff. But I think if you do that, you're simplifying a lot of this first version, right? And even it means there's a lot of vulnerabilities that you might have that get easily addressed or mitigated by the fact that at the moment, we're not worried about, individual outlying and the anonymizing user, because you have it the wider set. Because the bottom line is that deploying that versus not deploying already makes a massive difference, correct? Because at the moment, people have no freaking data.
So we do have some similar functionality, but not quite what you described. But I'll talk you more through that tomorrow, because I think we're out of time.
We are, and actually I need to jump to one meeting. I can't bail out. But I think this was great. I hope you guys got some value out of this.
Yeah, it's been great. I'd identified 4 areas that I think we want to talk about. There's the client-side sandbox of data, the centralized definition of who are the ethical approved healthcare authorities that we're working with, the data that we publish, the points of concern data, and that interaction point with the access code and the ability for a rogue employee or a rogue user to push incorrect data into the system. So those 4 areas, I think if we can laser focus on those tomorrow, and I'll come prepared to talk about them a bit more. And
can you drop that on the Slack channel, please?
Yeah, I was going to say the same.
Can I draw it on the Slack channel?
No, just put those notes. Just drop.
Oh yeah,
4 points.
Will do. No worries.
Yeah, and put the data there, and then what we'll do is we'll create stories for those. So we start to track them as individual stories, so that we can then create features and we create tasks from it, and we can kind of manage through there.
Cool.
Great stuff. See you tomorrow.
Thank you so much.
Thanks
See
very
you
much.
tomorrow morning.
Thank you very much.